Assalamualaikum warahmatullahi wabarakatuh and good morning. My name is Muhammad ALIF HAFIZI. So this is my FFV presentation entitled Silver Catalyst Free Radical Alkylation of METHYL NAPTHOQUIONONE. My supervisor is Dr. Najma and Madam Fazmi. So as introduction, naphthoquinone is an active compound which usually used in pharmaceutical and agrochemical area. Lots of research done regarding this compound. An example from Espinosa Bustos et al. In 2020 identified that this compound have variety pharmacological properties that can be applied for medicine and treatment. In addition, naphthoquinone derivatives are an alternative for low-cost medicine and very promising due to faster reaction and higher sensitivity. As the starting material for the reaction in this thesis is menadione, so menadione is one example of a vitamin K derivative which have beneficial in anti-cancer activity. So here are the problem statement. First, excessive cost of treatment and drug for cancer in terms of starting material and product form. Next, a very long step and time consuming to produce a medicine, make it not easy to done. And lastly, with the high cost of production of medicine. So here are a few research done on synthesis of naphthoquinone derivative which shown high product yield and easy method to follow. First, we have the oxidative methylation of NBS done by Kim et al. In 2001. From the research done, it showed the synthesis produced almost 98% of the product. Next, we have another research from Nakanishi and Baum in 2007. They claim that oxidation of 9,10-dihydroentrans with presence of catalyst produced 93% of product of yield. From this research, we conclude that with the synthesis process to produce naphthoquinone derivative was very easy and produced high yield of product. This literature review will be supported with the result from this thesis. So the objective for this research is to perform the free radical alkylation of methyl naphthoquinone, which is menadione 6. Next, to purify and isolate the product of alkylated methyl naphthoquinone, and lastly, to identify the isolated product via spectroscopy method, which is by NMR and IR spectroscopy. So for the methodology, here are the proposed method for synthesis to produce alkylated methyl naphthoquinone. First, menadione 6 and carboxylic acid, which is used in the assessment are glutaric acid, butyric acid and octanoic acid dissolved into 40 ml acetonitrile. The mixture then heated and added dissolved soluble nitrate into it. A solution of potassium persulfate was added dropwise into the mixture for an hour and continue heated until spot of product appear on the TLC plate. The mixture then cooled with 100 ml of dichloromethane and wash the organic layer with 50 ml distilled water for 3 times. Lastly, the mixture then evaporated in rotary evaporator and purified by column chromatography with specific solvent mixture. So for this compound 34, the synthesis method between menadione and octanoic acid. Based on the table identification by proton and carbon NMR, the compound was present in the spectrum. As we can see, there are present of CH aromatic bond in proton NMR at 2 peaks with quartet peaks for each. Present of alkene CH3 with singlet peak at 2.16 ppm and present of CH3 at 0.84 to 0.87 ppm. From carbon NMR, the aromatic CO shown at peak 184.45 and 185.78. Present of 4 peaks indicated the aromatic carbon bond. Another 4 peaks shown the CH2 peak and present of aromatic CH3 at peak 12.40. To support the compound CH3 at the end of the structure, is shown at peak 14.02 ppm. With the spectrum analysis, we can conclude that the product formed from the synthesis is the same as we predicted. So here are the spectrum of proton and carbon NMR used in this compound 24. So for compound 35, the synthesis was between menadione 6 and butyric acid. As we go through the spectrum, we can identify few components present in it, which shown the compound 25. First, from the proton NMR, the CH aromatic bond show between 2 peaks at 7.63 to 7.66 and 7.99 to 8.02 ppm. Next, the alkene CH3 bond with singlet peak at 2.13 ppm and 2 peaks for CH2 bond and another 1 CH3 bond at 0.82 to 0.85 ppm with triplet peak. To support this, we compare with carbon NMR present of aromatic CO bond at 184.61 and 185.20 ppm and alkene CCH3 bond at peak 143.70, and alkene CCH2 at 546.49 ppm. Next, another bond present which is aromatic C, show 4 peaks in the aromatic CH3 bond at 12.78 ppm and CH3 at 14.20 ppm. So, the product of synthesis was formed can be identified by the spectrum shown in the NMR. So, here are the spectrum for compound 35. So next, the reaction between menadione and glutaric acid form the compound 36. The analysis of this compound will be made by proton NMR and IR spectrum. The presence of 2 CH aromatic bond at peak 8.01 to 8.03 and 7.63 to 7.65 ppm with quartet peak both. Next, the alkene CH3 with singlet peak at 2.13 ppm and 2 peaks of CH2 bond. To support this, we compare with the IR spectrum, we show the CH band aromatic peak at 713.60 per cm. Presence of CC aromatic and CC alkene at 1589.97 and 1652.08 per cm respectively. The OH stretching at peak 3783 per cm show the presence of functional group of OH in the product, and the other 2 peaks of CO carbonyl and CH alkene. All these peaks in both spectrums show the formation of compound 36 was successfully done in this synthesis. So here are the proof of spectrum for compound 36. So as the conclusion, free radical alkylation reaction of menadione 6 with different carboxylic acids successfully produced compound 34, compound 35 and compound 36. For the confirmation of the compound, we analyze the compound by proton NMR, carbon NMR and IR, and all peaks present in the spectrum show the properties of the product formed. After completing the synthesis step for all the carboxylic acid, for the further research and study, we recommend to increase the temperature of the reaction to reduce the time of synthesis for the formation of the product, and using different type of organic acid for the naphthoquinone formation. So here are the list of the references used in this thesis.